Hello, my name is Mariam, 46-MPT, and we are Team 28. I want to introduce the idea of our project, which is a smart disc lamp. The components that we've used are an IR obstacle sensor, a 7-segment time display, a light sensor, and a lamp, and the FPGA board. The idea of the project is when someone sits on a chair, the IR sensor will detect this person, and the time will start. Moreover, the light sensor will detect the light intensity of the room, and accordingly, the lamp will turn on or off. As an example, if the light intensity of the room is high, so there will be no need for this lamp to turn on, so it will not be turned on. And if the light intensity is low, so it will be turned on. Finally, when this person leaves the chair, the IR sensor will also detect this, and the timer will stop counting, and it will display the total number time taken by this person to stop.
Hello, my name is Ahmed, 46-2859. I will show you how the timer works. So we had to find a way to know when every second passes, so we decided to use the FPGA board internal clock. The frequency of the clock is 50 megahertz. So with every 50 million ticks, the 1 second passes. So I will show you the code. Here is the clock. It is an input bit to the VHDL file. And here's the architecture. We use 7 signal variables, one for the ticks, and the other 6 are for the seconds, minutes, and hours. They are for the right and left digit of the seconds and the minutes and the hours. And here's the process. With each process of the clock, we check if it is a rising edge, and if it is a rising edge, the ticks are incremented. Here the ticks being incremented. And once the ticks reach the clock frequency, which is 50 million, we set it as the constant here. Once it reaches the clock frequency -1, the ticks are being reset to 0, so we can increment again to 50 million. And once they are reset, then 1 second has passed. Okay, so we check. We go and increment the seconds, the right part of the seconds, and if it is 10. If it reaches 10, then we have to increment the left part of the seconds. So if it is 19, we have to be 20, and if it is 29, we should go to 30, and this part. And if it reaches, if the left part is 5 and the right part is 9, then we have 59 seconds, and we should increment to 60, which is 1 minute. So that's why we reset the seconds, right and left digits, and we increment the minutes. And we increment the minutes parts the same way as we did to the seconds. If the right part reaches 10, then we reset it to 0, and we increment the left part. And if the minutes reach, the left part reaches 5 and the right part reaches 9, then we reached 59 minutes. So when we increment a minute, we should get to 1 hour. So we reset the minutes, right and left digits, and we go to 1 hour. And the same way for hours, as we did in the minutes and seconds. And when hours reaches 23, and the minutes reaches 5:09, and seconds reaches 5:09, we reset the counter, and it starts from 0 again when 1 full day passes. And then we put the signals to the other component into 7 segments, and it will be demonstrated later how the values are returned and displayed on the 7-segment display.
Hello, my name is Ahmed Belal, 46-0642. I will show you how to display the seconds, minutes, and hours on the 7-segment display of the FPGA board. Now I will show you the code. In the smart lamp module, there are 6 outputs. Each output is 7 bits. Each bit is Each bit, each output is for the outputs are for the left and right digits for seconds, minutes, and hours. And in this port, we connect the smart lamp module with the N to 7 segment display module. In the N to 7 segment module, we imported this library to use integers. In the entity, we have an input, which is an integer, as the second, minutes, and hours are integers, and the output is 7 bits. Each bit is for an edge in the 7-segment display. This 7-segment display is active low, so if an input to an edge is 0, it will be turned on, and if it's 1, it will be turned off. So we used a select statement. If it is a 0, we want all these bits to be turned on, so they are 0, and this bit is the bit in the middle. For the edge in the middle is 1, because we want it to be turned on, off, and all are the same as all integers are the same as 0. And this is the package for into 7-segment display. And here we send the input of the signals of the left and right digits for seconds, minutes, and hours. And this is the output of the 7-segment display.
Hi, my name is Nouran Ayman. I'm going to explain how the IR sensor works. First, we connect the ground of the IR sensor to our FPGA board, and then we have the VCC, which is connected to the VCC of the FPGA board. It has 5 volts, and then we have the digital output, which is connected to the FPGA board, which is connected to our code here. If someone approaches the IR sensor, it turns from 1 to 0. Now I'm going to show you the IR code. Here's the input of our IR. And here's our if condition. If the IR is equal to 0, that means that someone has approached the IR sensor. Thus, the timer will start to work, and our light sensor will also start to work.
Hello, I'm Omar Ashraf, 46-5347, and I will be explaining the light sensor and the lamp part. The idea is when the IR sensor senses someone and the room intensity is low, or in other words, the room is dark, the lamp will light up normally. However, if the IR sensor senses someone at the desk, but the room intensity is high, or the room is lit up, the lamp will not be lit. And we will show a demonstration now. So now the IR sensor is working, but the light intensity is high, so the lamp will not light up. But if we remove the light intensity, the lamp will light up normally. So this is the code for the light sensor and the lamp part. The light sensor is given as input and the lamp is output. So when IR equals 0, which means when the proximity sensor is working, or the IR sensor is working, then it will do the code for a timer, and then at the end it will propagate the light input to the lamp output. So when the light intensity is high, it will give 0 here, and when it is low, it will give 1. And when the IR sensor is not working, the lamp will be set to 0.
And now we will show you a simple demonstration. So once she sits, the IR detects her. So we are studying at night, so the lamp is currently working. And if you are studying at morning, the light sensor, the lamp will turn off. So if it turns to night again, the lamp will turn on. And here's the timer working. And once we get away from the desk, the timer will stop working and the total time will be displayed. And that's it.